Welcome everyone. Today I'll be demonstrating the Building Energy Management open source software, or popularly known as the BEMOSS user interface, developed by our research group at the Advanced Research Institute at Virginia Tech. On the screen, on the left-hand side, you're seeing the BEMOSS user interface, and on the right side are all the devices that I will control through the user interface in this demo. So let's have a look at the home page of the BEMOSS UI. On the home page, it's a summary information related to your energy management system. We are representing a two-building setup here named as home and lab. However, you can add multiple buildings, more than 2, 3, 4, and name them accordingly based on your setup. On the left-hand side, on the interface, you see the auxiliary functions of the BEMOSS, discovering new devices, manage users, and all of those things. Now, BEMOSS is capable of communicating with different types of devices with different communication protocols, such as Wi-Fi, Zigbee, and Ethernet, and different data exchange protocols, such as BACnet, Modbus, and web technologies such as JSON and XML. On the screen, you see on the two building setup, on the home building, we have 10 devices of different types: HVAC, which is thermostat, lighting, plug load, sensor, power meter, and distributed energy resources. And on the lab, we have 5 devices under the lab building: lighting, plug load, sensor, and power meters that I'm going to show how we can control from the BEMOSS UI. So let's start with how we can control the lighting through BEMOSS UI. So this is a light, traditional LED light that you see in a normal commercial building that I'm going to control. We can control smart switches as well. And this is the page that you get a summary of all the lighting devices. As you can see, it says the status is off right now, and it's online, meaning the device is communicating with the BEMOSS. Now, if I go into it, you can see again a summary of device level status. Right now it's off and brightness is 0. I can easily switch on the light by toggling the status tab and submitting changes. If you noticed, as you can see, the light turned on. On the right hand side here, this YOLO pop-up, that means whatever action I did take, it's already stored back in the database. That means it's written there that VTARI at that time turned on this light at 100% brightness. Now moving on, I can control the brightness from here as well. For example, it's too bright, so I can reduce the brightness to up to 21%, and I can control the brightness there as well. Again, I made some changes, so it's stored back in the database that I reduced the brightness to 20%. So that's how we can control the lighting devices from the BEMOSS. And these data, as I said, are saved in the backend database as well. This is the historical data. As you can see, the lights were turned off, and then I turned it on at 100% brightness, and then reduced the brightness to 20%. So all of these data are there. I can also set schedule for the lighting devices. So you can add multiple periods and specify on which days you want the light to maybe turn on or reduce the brightness. For example, maybe around 6 a.m. in the morning, you want the lights to be turned on at a 50% brightness. So you can schedule those things in BEMOSS, and BEMOSS will take care of these things automatically. So that's how we can control the lighting devices, can see the historical data, and reduce brightness as well. Now, let me quickly turn off the light because it's too bright. So the light has turned off. So now moving on back again to the home page, from the lighting devices, I will show you how we can control thermostats from the BEMOSS UI. Now we have different types of thermostats that we can control from the BEMOSS UI. For example, this is a thermostat here, which is connected to the fan. We don't have an AC in the lab, So we're going to represent the fan as the AC to show how the thermostat actually operates through BEMOSS UI. This is the status page for a thermostat. As you can see, the indoor temperature of the room right now is 76, and the thermostat is in cooling mode, and the cool set point is 78. That means the room temperature is actually lower than the set point. That's why the AC represented here by the fan isn't working. However, if I change the cooling set point from 75 to say 72, and then I can, similar to the lighting devices, when I submit the changes, as you can see, the set point changes and the fan turns on. So this is how you can control the cooling set points, the thermostat mode, the fan mode, all of these things from the BEMOSS UI. So let's look at the historical data as well. As I showed you earlier, that all of those data are actually stored back in the database. So it was 78, I pulled it down to 72. You can see those information being reflected into the historical database. We can set schedule as well for the thermostats. Once you add a schedule, then the software will take care of that automatically. So if you maybe at around midnight, if you want your cooling set point to be much higher because nobody's in the room, maybe 80. And then early in the morning, if you want to pre-cool the room, say for example, around 4 a.m., you want the room to be pre-cooled. You can set all of these functionalities from the BEMOSS UI, and the software will take care of it by itself. So that was the thermostat functionalities. Now I'll show you how we can control different types of plug loads from the BEMOSS UI. I'm showing two plug loads here, and the plug load that I'm going to control is this one. So it's turned on off right now, as you can see from the status. Just toggling the switch using the UI is very easy, it's intuitive, it turned on. Now this plug load gives me the power and the current and the voltage information as well. A 20-watt bulb is connected to it. As you can see, the data is coming here. And we can see the historical data as well. I just turned on the light. As you can see, it was turned off. Then I turned on the light. And I can set schedule for the plug load similar to thermostats and lighting devices. So if you want the plug loads to be turned off or turned on at a particular time, you can set the schedule from here, and the BEMOSS UI will take care of it. Now moving on from plug load, we also have different power meters that we can read for BEMOSS UI. Now this particular power meter is actually connected to the light that I just turned on a little bit earlier. Right now, the light is not working, so the power meter is reading 0 watt. Let me turn on the light and I'll show you an interesting use case here, that how we can save some energy just by adjusting the brightness. So the light is turned on right now. As you can see, I turned it on. And if I go to the power meter, as you can see, the light at 100% brightness is consuming 36 watts of power. Now I don't need 100% brightness, it's too bright. 20% brightness is good enough for me. Even sometimes maybe 20% is too much. So let's reduce the brightness by 50% and see how much energy we can save. Again, I made all of these changes. The light's brightness is reduced to 5%. And as you can see, or I can see from here rather, that I can barely tell the difference. So let's now go back and see how much energy it saved. It saved about 9 watts, which is 25% of the previous one. From 36, it went down to 27, just by reducing the brightness from 100% to 50%. That's an automatic savings for you or the building energy manager. So, and you can do all of this analysis using different types of devices that are being centrally monitored and controlled through the BEMOSS UI. Now, we also have historical information here. As you can see, the power consumption information stored here. When I turned on the light, it went up, and when I reduced the brightness, it went down. So let me quickly turn off the light right now. Now, from the power meter, we also have CO2 sensors, carbon dioxide sensors, that we can monitor from the BEMOSS UI. For this, this is a CO2 sensor that you just saw in the BEMOSS on the table. Let me quickly turn off the plug loads from the UI as well. All right. So let's look at the CO2 sensor right now. So it's this data is the real-time data right now. You can see the temperature of the room, the humidity of the room, what's the CO2, it's 590 parts per million right now, what's the noise, pressure, what was the maximum and minimum recorded temperature in the past 24 hours. Now, if you go back, you can see the historical information here as well. What was the pressure? As you can see, the CO2 here is building up in this room gradually because we're in the room right now, so it's building up. This is actually a very important, useful information to have. For example, if you have an enclosed classroom where students are taking classes, if you have this sensor and you can monitor the CO2 buildup over the time, you will be able to see whether you need to flush a fresh air into the room or not. So BEMOSS can also monitor those things. We also have an illuminance sensor that we can monitor from BEMOSS UI. This is an illuminance sensor that's monitoring the lux level of the room. As you can see, the lux level is about 225 right now. This is the real-time data, and it keeps updating as the illuminance level of the room changes. So this information can be very useful. If you have a lot of sunlight available in your space, you can use this information to control the brightness of your room and adjust it accordingly so that it's comfortable for you. Similar to other devices, you can see the historical illuminance data as well. As you can see, the illuminance level of this room is going up and down due to the lights being turned off sometimes and then getting turned back on. So this is how we can monitor a room's illuminance level through BEMOSS UI. So moving on from the sensors, we also have distributed energy resources that we can monitor from the BEMOSS UI. So let's have a look at how we can monitor the status of a rooftop solar panel from the BEMOSS UI. This is an actual rooftop which is on top of our ARI building right now. It has a generation capacity of around 6.5 kilowatt. Today is a very sunny day outside. As you can see, it's producing about 5.6 kilowatt of AC power right now. So these are all real-time data. The solar panel is generating PV electricity right now, and that's being directly pushed into the building and being used. So this is very interesting information to have a look at it. You can have the DC voltage. You can see the DC power and AC power, also DC panel voltage and inverter output of AC voltage. What's the current, DC current and AC current? What's the efficiency? What's the temperature, ambient and module temperature? What's the irradiance, wind speed, all of those things, and the power factor as well. Now, these are real-time data. However, BEMOSS stores the historical data as like all the other previous devices as well, which is very important or helpful in terms of doing your PV electricity generation analysis. As you can see on the graph, it shows the past 24-hour information. What was the PV electricity generated by the PV module? Right here, as you can see, it's quite sunny here. It started producing from around 6:30, 7:30 when the sun came up here. and then some clouds in between, and then started picking up again right about noon here. So you can also see what was the panel voltage and the AC voltage. You can see the current as well, AC and DC both. You can see the temperature, what is the ambient and module temperature. You can see the wind velocity and all of those informations. Now, you can actually download historical data from the software as well. For example, I want to download, let me give a little bit more range, maybe from 26 to today. And you can export all the data in a CSV. So you basically have 3 levels of data that you can access through BEMOSS: real-time, past 24-hour, and also historical data. So on the screen, you see the CSV that are downloaded that has the historical data from 26 March up until today, right now. And all the data, the efficiency, how much energy was produced, what was the power output from the PV, and what was the power output from the inverter. All of this data you can do historical analysis using BEMOSS UI right now. And all the data, the efficiency, how much energy was produced, what was the power output from the PV, and what was the power output from the inverter. All of this data you can do historical analysis using BEMOSS UI. We can also use Alexa to control these devices via BEMOSS. Let me demonstrate. Alexa, launch Smart Lab.
Welcome to test BEMOSS.
Turn on the office light.
Okay, done.
What's the brightness of the office light?
The brightness of office light is 100.0.
Make it 20.
Office light's brightness has been updated to 20.
Turn off the light.
Control of light status failed because no such device found.
Turn off the office light.
Done.
Alexa, end.
Thank you for using the BEMOSS Alexa commander. Have a nice day.
So that was a brief demonstration of the BEMOSS UI. BEMOSS is a low-cost, scalable building energy management solution that can monitor and control different types of devices. All the devices that I demonstrated here and can be monitored and controlled by BEMOSS are off-the-shelf, readily available products. And the solution can be both a local solution within your own network, or it can be a cloud solution via your modem or router. Thank you.